So welcome back everyone, welcome back to the second part of the lecture. In this part we will continue talking about carrier sense multiple access part 2. The objectives here to know the various multiple access protocols, understand CSMA with collision detection, and then CSMA with collision avoidance, the details of each one of them. We know that the CSMA protocol works like according to the principle of sense before transmit or listen before talk. Carrier busy, transmission is taking place, carrier idle. When the carrier is idle, it means no transmission currently taking any place. So let's get started with the CSMA's collision detection. In this protocol, if two stations sense the channel to be idle and begin transmitting simultaneously at the same time, they will both detect the collision almost immediately. Rather than finishing transmitting their frames, what would they do? They should abruptly stop transmitting as soon as the collision is detected. This is the beautiful advantage, the beautiful merit of collision detection CSMA based protocol. Whenever it transmits its data, it transmits its frame, but if a collision is detected, it doesn't continue transmitting its frame. It just stops immediately. No need to continue wasting my energy and resources to complete the transmission of a frame that I'm pretty sure is not gonna go through because of collision. So this is the beautiful thing about collision avoidance. So it quickly terminates. This protocol quickly terminates damaged frames, thus saving time and bandwidth. It saves time and bandwidth and power as well. Power, because if you were to continue transmitting, you would waste too much power compared to the case of stopping your transmission immediately after detecting a collision. So you save time, bandwidth, and power. So carrier sense with where is that used? Mostly is used in LAN networks, computer networks, wired networks, and it's implemented in the MAC layer. Ethernet is also using this protocol. So let's just give a visualization transmission process to understand how carrier sense multiple access collision detection works. So let's assume that we have this transmission time period. We have a node that has finished transmitting frame 1. We call it the transmission period. And then after finishing the transmission, after all the nodes finished after a certain node finishes its transmission, the nodes will enter into a contention period. This contention period, think of it like the nodes are rivaling with each other to seize the channel so that they can transmit their data. So all the nodes contend with each other and compete with each other in order to access the channel. The node that senses the channel first and finds it to be idle starts transmitting and makes the channel busy so that all the other nodes backs off. Once one of the nodes get the schedule or get the permission from the channel that it can transmit now, it sends its data. After it finishes sending its data, again it frees the channel, it leaves the channel, and the channel will enter again into a period of contention. It means competition among nodes to access the channel. Again, the node that gets access, the node that's able to seize the channel first will transmit its data, and then it will leave it for others to transmit. If nobody has any data to transmit at this point, no node has anything to transmit, the channel will be in the idle mode. Idle mode, it means that nobody is contending, nobody is competing with others to seize the channel, and nobody is actually transmitting until a frame senses the channel, and until a frame has data to send, and then it senses the channel, and then it sends its data over the line. So if we were to summarize this again, at the point marked T0 here, T0, this is T0. A station has finished transmitting its frame. Any other station having a frame to send may now attempt to do so. If two or more stations decide to transmit simultaneously at the same time, there will be a collision. Collision can be detected by looking. This is very important. How can you detect collision? You might see this a question in the exam or in your test. How can you detect collision? How nodes can detect collision? So collision can be detected by looking at the power of or pulse width of the received signal and comparing it to the one you transmitted. So you transmitted your signal, which carries your data, and you already have a stored version of it at your buffer. You compare it with the received pulse after transmitting it. If the power is different from the one you transmitted, or the width is different, it means that there is a collision. Why? Because if any packet, any frame, any signal collides with another signal, it means it convolves with the other signal. If two signals convolve with each other and affect each other, then their shape, the resulting shape, will be different from any of them, and their period, the period of the resulting signal, will be equal to the sum of the periods of all the signals involved in the collision process. And I know that most of you may not understand this by just mentioning it this way, because many of you didn't take signal and system course. But for those of you who are expert in signal and system, who knows convolution, I don't know how many of you knows convolution here, but like for those of you who knows how signal work and they know convolution process, basically if two signals get mixed with each other, this mixture process is called convolution. Basically, they don't get multiplied. They basically get convolved with each other. Convolution means that the shape of one pulse will get affected by the shape of the other pulse, and the resulting signal will have a duration equal to the sum of the duration of the two individual pulses. So if pulse 1 has a duration of 10 milliseconds and pulse 2 has a duration of 10 milliseconds, and they convolve with each other, they collide with each other, then the resulting signal will have a duration of about 20 milliseconds. So it doubles. Another thing, the shape of the resulting signal will not be any of the shapes of the individual signals, will not belong to any of the shapes of the signals entering the process of convolution. You will get a completely different shape, and this is an indication, a clear indication, that there is a collision happening in your media, and therefore you stop your transmission process immediately. There is no point of keeping your transmission until you finish it, because it's gonna be vain. It's gonna be waste. It's gonna be waste of resources and waste of power and energy. After a station detects a collision, it aborts its transmission and then waits a random period of time and then tries again, assuming that no other station has started transmitting in the meantime. Therefore, the model for CSMA collision detection will consist of alternating contention and transmission periods, as I just explained to you here, with idle periods occurring when all stations are quiet. So this is the process, basically, alternating duration of transmission periods and contention periods and idle periods. Idle periods, nobody wanting to access or transmit the channel. Contention periods means many nodes are competing with each other to transmit. The one that seizes the channel first gets the right to transmit. Transmission periods means a node's transmission is taking place. This is what it means, and these are the key properties and features and attributes of this CSMA CD protocol. How do you calculate its efficiency? Efficiency is very important metric that allow us to measure if the protocol is effective or not. So how do you measure the efficiency? The efficiency, I'm not going to ask you to derive the formula. The formula is given for you. And this formula has certain way of calculating it. You may find it in research papers, how authors and researchers were able to calculate it. But at the end of the day, the formula is found to be equal to 1 over 1 plus 6.44 multiplied by A, where A is a factor depending on the transmission time and the time of the packet that you want to transmit. A transmission time here equal to round trip time of 1 bit, which is equal to 2 multiplied by the propagation time of your bit. And this is the transmission time. The transmission of 1 packet is the time needed to send the content of 1 whole packet, which is equal to 1500 bytes. So if distance increases, do you think the efficiency will increase or decrease? If distance increases, what will happen? If distance increases, what will happen to TT, the transmission time? The transmission time will increase as well. And therefore, what will happen to A? If TT increase, A will decrease. And if you divide 1 over something that's decreasing, then the efficiency overall will decrease. If distance increases, efficiency of CSMA decreases. If distance increases. So I may ask you in the test about the relationship between TB, TT, and the efficiency. So what will happen if TT increases, if TB increases, if it decreases, like I remember one of the questions in the midterm was like this about the throughput. A throughput of ARQ. Very few number of students were able to answer it correctly. You need to be able to relate. You need to be able to read the equations correctly, understand them, and connect the variables with each other. So CSMA is not suitable for long distance networks like WAN, but works optimally for LAN. Why? Because of its decreasing efficiency when the distance increases. If the length of your packet is bigger, the efficiency of CSMA also increases. Why the efficiency increases if the length of the packet is bigger? Because in one shot you transmit as much data as you can. So basically you utilize the bandwidth effectively. But maximum limit for length is equal to 1500. Why do we have maximum limit? So that we give opportunity and chance to other nodes to transmit their data. Although when you give chance to other nodes to transmit their data, you end up having you will experience the contention period, which will maybe cause which is gonna cause delay because the nodes now are competing with each other to access the channel, and the collision might happen. Therefore, the degradation in the efficiency of our system is mainly happening when you go to the contention period, the accessing process, coordinating who should transmit now, who has the right to transmit now, what will happen if there is a collision, how long, how much time you are supposed to back off if there is a collision. All these reduces the efficiency of your system. So when there is signaling means handshaking between the nodes. This will affect your efficiency, decreases your efficiency. When there is collision, it will affect your efficiency, decrease it basically. If there is contention, collision, handshaking, signaling overhead, reducing the size of your packet, all these are factors to reduce the efficiency of your system, reduce the throughput, increase the delay, and therefore the overall performance is not gonna be optimal. So these are the things that I want you to remember about CSMA collision detection when you are studying it.